My name is Mike Heroux, and we're preparing content for the 2020 Collegeville workshop on scientific software, the emphasis on developer productivity. We're here talking with Anshu Dubey and our tech person, Margaret. And so maybe Anshu, you want to introduce yourself, and then Margaret can do the same.
Right, thanks. Thank you, Mike, for inviting me to this interview.
Oh, it's a pleasure.
My name is Anshu Dubey. I work at Argonne National Lab as a computer scientist. What I'm known for is multi-physics, multi-component code that has become a community code for at least 6, if not more, scientific domains. And the code is called Flash. And I've been involved in all aspects of it. And in the process of this code's evolution by organic development, I've become a person who's very concerned about issues of software engineering and software productivity. To you, Margaret?
I'm Margaret Heroux, and I am a student at St. Ben's, and I will be working on editing videos and posting them to YouTube for this conference.
Let's get started. So the conference, Collegeville Conference workshop is about developer productivity, and I'm hoping that you would be able to talk a bit about your practical definition of developer productivity. And then I think you're very interested in some of the cultural aspects, things that we can improve developer productivity by culture. So take it away.
Right. Thank you, Mike. So I would right away push back on anybody's attempt to define developer productivity in any very specific term, because like for any creative endeavor, it's very hard to pin down how are you going to measure productivity. Simple measures like measuring the lines of code that someone is contributing is a very not even perfect, sometimes misleading measure of how you're going to measure the developer productivity. So to some extent, it comes down to subjective evaluation of people's work. So in my team, when there are people working, because I've worked very closely on the development and I continue to be involved in day-to-day discussions of where the design and the implementation and the modifications are going, in all of those discussions, I have an idea of where the contributions are coming from and how soon are people able to do their work. So all of that goes into how I judge the productivity of various members of my team. Now, this would be a difficult thing to do in a large team, I can believe. And it's a large spread, just a very spread over team, because then you really can't be having these kinds of discussions and you can't be keeping track of everybody's work. So there, to my mind, what is easier to spot is lack of productivity rather than trying to measure who is more productive. So, and I think for a person who's managing a product, this ability to pinpoint that someone is being less than productive is usually good enough so that they can work towards getting around that problem. And that is easy to measure in terms of, the mining tools have gotten sophisticated enough that you can tell when someone is just making incremental contributions and not substantial contributions, and that someone is taking too long to complete the issue that in your judgment should not have taken so long, et cetera, et cetera. Yeah. So just like any other creative endeavor, this is a somewhat holistic and project by project thing that you do. Is assessment of productivity.
So just let me ask you to clarify. So you're saying then that it's not so much that you necessarily have to measure positive productivity, is that it's easier to look for lack of productivity, and that's what you focus more on than trying to. Is that a fair summary of what you just said?
Yes and no. So I'm saying that when you are in a situation where you cannot be personally monitoring your entire team, then it is definitely easier to look for lack of productivity and address that. In a smaller team, when you're interacting with your team on a daily basis, it is much more positive in the sense you really do know who's being productive in what way.
Yeah. And when you measure, when you think about that, what things do you look for? I know we can look for, activities, contributions, but there are specific things. For example, going back to the number of commits, right? That I guess you would argue that's not a sufficient measure. What other activities do you look for that would help us measure that?
So, for example, through the analysis of complexity that mining tools can do, you can tell when the contributions that a person is making are just adding very incremental value to the code that is there, that there is no substantial big chunk that's coming in, that there hasn't been much of thinking and creativity gone into the code that a person is adding. The second one is, of course, if they're taking very long to resolve an issue that seems to you should not be taking this long, then you measure that against the amount of work they've been assigned, because you have to also monitor whether some people work better when they have more than one task so that they can switch when they're stalled. Some people like to have a single task. And so when you're managing a team, you have to keep all of that into mind, and all of that has to be judged against what your eventual goals for the project are.
All right, very good. Would you argue that also looking at things like who's reviewing pull requests, who is writing good documentation, are those other ways of looking for that substantial contribution?
It definitely would be. So definitely in my book, someone who does huge amounts of inline documentation gets a big plus, because in the early days of when I started working on Flash, the fact that some of the earlier developers had really written copious amounts of inline documentation made it really easy to understand their code and to have confidence in modifying it when we needed to. So yes, that definitely gets a big plus. And yes, there are other measures. So like I said, what you judge and what you measure depends upon the culture of the project and culture of your team also. Yeah. And one part of the productivity also is how well is a person integrating in the team.
Yeah. Any other comments? Any other things you'd like to say?
About developer productivity, no, I think the only thing that I would say is that in this, as in anything else, being effective in leading your team is much more by being guided by research as opposed to being told by research.
Yeah.
That's the only mantra I take with me in adopting all practices.
Yeah, that's an excellent statement. So you had what I consider a provocative white paper submission to the workshop. Would you like to talk a bit about that?
Yes. So in some sense, what I have observed in the scientific world, so this would be in the time frame of 2008, 2009, when the first PSAP program was announced by the ASC Alliance Center, that, or maybe it was the co-design, where Agile first came on the radar of people working in the DOE labs and scientific software. And at that time, Agile was becoming popular in the enterprise software because it was taking the enterprise software away from what was, for many projects, extra heavyweight process that actually impeded people's productivity. And so Agile was a good move for them to make. Now, my experience comes from the other extreme, that is the applications, science domain application codes. And if anything, that you could describe as Agile on steroids, because that really was driven by, okay, I have a next paper that needs to come out and I need to publish that. And therefore the client, which is the self, is perpetually driving the development cycle. And so in that sense, what Agile would bring to the scientific software development would be actually bringing a little bit of a braking procedure to the rapidity and actually thinking about it a little bit more and incorporating process on it a little bit more. So that was a good thing. But then the next thing that I encountered was that in all of the scientific software code that I've been involved with, there is always the backbone, which acts as the thing off of which the capabilities hang. So this is the thing that sort of gives a shape and structure to the code. And getting that wrong can be extremely expensive going forward. So, and this came because when Flash originally started, it was basically three codes that were sort of smashed together and were made to run because there wasn't anything that the scientists had with the same kind of capability. So they needed a code very quickly. So obviously there wasn't enough time to think about what this backbone ought to look like. And very quickly it became obvious that the way in which it was brought together was not going to be sustainable or extensible in future. So as soon as the first code was available to the scientists to work on, we embarked on this task of refactoring the code, but this time actually deliberating on the design and getting it right, so that we actually have something that is less changeable. So in all my presentations that I make about software design, I differentiate between the parts of the code that are sort of long living and therefore need to have a waterfall-like requirement gathering and implementation, and then the codes that are capability codes that are perpetually driven by the research going on in the field that should be following much more of the agile process.
Yeah. Yep.
So that's the distinguishing thing that I want to bring to people's focus.
Yeah. And I think in my own experience, likewise, that backbone that you called it, between a well-designed backbone, a poorly designed backbone, really does make a difference over the long time arc of scientific software code base. Yes. That's an excellent statement.
Yes.
Very good.
And then embedded within that backbone design is the agile process, because every time you're exploring the design space, your prototype building is following agile process. It's only whatever prototype makes into the ultimate semi-permanent or relatively permanent code is what really, so what's going is that all of the wisdom acquired through these processes of design space exploration keep getting accumulated into the requirement, what would be considered the requirement gathering phase, and ultimately result in a robust backbone.
All right, very good. Any other comments you want to make before we wrap up?
About the cultural change, which concerns a lot of us, because in some sense, I've grown up in the times when people like me really didn't know where they belonged, because it's the breadth that I bring to the research, not in depth anything. And for the longest time, for most of the people in the physics and applications areas, we were nothing more than glorified technicians. There wasn't a recognition of intellectual creative contribution brought in by the scientific software developers. And so I think in much the same way that it's happening around us in the world, I think what it is that one shouldn't get discouraged by not being heard immediately. I've been reading this very interesting book called Slow Thinking and Fast Thinking. And one of the things that it tells you is that when you've been exposed to an idea, your fast thinking system becomes primed to be able to take in that concept and pass it along to your slow thinking process, which actually makes the reasoned decision making. And
Yeah.
so by continuously talking about things that are important to you, things that you want to see changed, even if it seems like no one is hearing, and even if you think you're beginning to sound like a broken record, I think in the end, you are creating a critical mass of awareness among people that this is an important issue. And then there comes an inflection point where that takes hold. I think that's what's going on with the Black Lives Matter movement in the world at large. That's what went on with the gay marriage in world at large. And I think that's what we're beginning to see, that the software sustainability has gotten the same kind of inflection point in the last few years.
Yeah, that's excellent observation. Yeah, that's Thinking Fast and Thinking Slow, right, by Danny Kahneman. Yeah, it's a great book. I really like that book. Yeah.
Yes.
Yeah. System 1 and System 2.
That's absolutely right. Yes.
Yeah. Very good stuff. Yeah, and a really nice mention of that relative to software productivity and sustainability. So great, thanks.
Yes.
And any other comments, Anshu? Thank you very much.
No, just it's a great thing that you're organizing these workshops. I think they're a great place for us to get together and exchange views. So thank you.
Yeah, no, you're very welcome. Yeah, it's actually a great privilege to be able to bring people together and have conversation and create connections across the community. So it's a wonderful place to put some energy into that we hope will pay off as we go forward in the future. So thank you for your contribution to it.
Thanks very much.
Yeah. All right, very good. Well, thank you. And thank you, Margaret, for your tech work and the post-processing you're going to do of this. So, and we'll say goodbye and